Hi friends, now we will be having one tutorial session, and in this session we will solve some numerical problems based on the discussions of last 4 classes. So, problem number 1 says that calculate the sedimentation rate in gravity separation for the particle size limiting to delimiting 7 micrometer, the particle density equal to 1040 kg per meter cube, liquid density is 1000 kg per meter cube, and viscosity of continuous phase 1 into 10 to the power minus 3 Newton second per meter square. So, this is the problem we have to solve, and in the previous class we have discussed on the coal cleaning part that the size and terminal settling velocity is used for the separation of particles in case of classification. So, here we will see if a particle size of coal particle is known, then what will be the terminal settling velocity. That is very fundamental aspect we have provided here, and we will discuss on it. So, what we will do, if we assume the laminar flow conditions, then Stokes law is applicable, and in that case we can find out the terminal settling velocity as per this formula, that is terminal settling velocity is equal to dp square into rho s minus rho l into g divided by 18 into mu, when dp is the diameter of the particle, rho s is the density of the solid particle, rho l is the density of the fluid under which the particle is falling, g is the acceleration due to gravitational acceleration, and then mu is the viscosity of the media. So, we have to calculate Ug. Now, we will say what is the value of dp. dp is given here, that is 7 micrometer. So, we have to convert it into meter unit. So, 7 into 10 to the minus 6 dp we are getting, and then rho s is given 1040 kg per meter cube, and rho l is given as 1000 kg per meter cube, and g we know that 9.81 meter per second square, and then mu value is given also 1 into 10 to the minus 3 Newton second per meter square. So, in this case we will be getting the Ug value as 7 into 10 to the minus 6 square as dp square, then 1040 minus 1000 into 9.81 divided by 18 into this is 0.001. So, this is equal to 1.068 into 10 to the minus 6 meter per second. So, this is the terminal settling velocity of the coal particle. Our next problem statement says, in a fixed bed gasifier, air flow rate and feed flow rate are 10 normal meter cube per second and 8 kg per second respectively. The feed material does not contain any sulfur, nitrogen and chlorine. The syngas contains carbon monoxide 40%, CO2 2%, H2 30%, CH4 5% and C2H2 2%. Calculate the rate of production of syngas in normal meter cube per kg of the feedstock. So, this is the problem statement. We have to calculate the production of syngas, the normal meter cube per kg. So, 1 kg of material will produce some amount of syngas, that amount we have to measure in terms of in the unit of normal meter cube. So, how we can do it? We can solve this problem by nitrogen balance, as we have discussed in the previous classes, that fuel gas production normal meter cube per kg of feedstock, that is equal to air flow rate normal meter cube per second into 0.7 9 divided by 1 minus the CO plus CO2 plus H2 plus CH4 plus C2H2, that is the composition of the flue gas, by 100 into feeding rate of the feedstock. So, feeding rate of feedstock, this is the total amount we are using per unit time, and then 1 minus this term is giving us the nitrogen available in the flue gas. This part is giving us the nitrogen available in the flue gas, 100 minus this whole term. So, flue gas production, then what was the nitrogen in the air which was used in this case? We are assuming that 21% oxygen, so 79% nitrogen is there. So, that is why this term is 0.79. So, air flow how much into 0.79, that is the nitrogen available in the air, and then that is the nitrogen coming, and what is the nitrogen available in the flue gas, that is flue gas production rate into this one, and this is divided by the amount of material used. So, this formula is used to calculate the flue gas production, that is in the unit of normal meter cube per kg. So, this we have discussed in the previous class. Now, we have to put the value of these things. So, what are the value of CO? It is given CO 40%, CO2 2%, H2 30%, CH4 5% and C2H2 2%. So, this value we will put there, and it was also given the 10 normal meter cube per second. This is the air flow rate, and 8 kg per second was the feed flow rate. So, all the terms are given in the problem, and we will be putting those things. So, 10 the air flow rate into 0.79 divided by 1 minus, that is equal to CO 40%. So, 0.4 as 100 is divided here. So, this is equal to 0.02, 2% CO2, and then 30% hydrogen. So, 0.3, and then CH4 was 5%. So, 0.05, and then C2H2 was again 2%. So, 0.02, we are getting this term, and then this feed rate, that was 8 kg per second. So, multiplied by 8. So, this is the syngas production rate, and now we are getting by calculation 7.9 by 0.1 into 8, that is equal to 4.702 normal meter cube per kg of the feedstock. So, now we are able to find out what will be the production of syngas per kg of feedstock. The next statement says a peat sample has the following composition on mass basis. So, carbon 37.5%, hydrogen 8.8%, oxygen 27.6%, N 0.40%, sulfur 0.10%, moisture 20.5% and ash 5.1%. Determine the molecular formula and heating value of the peat sample using the following relation on wet basis and dry and ash-free basis. So, the formula is given HHV, high heating value in megajoule per kg, is equal to 0.3516 into C plus 1.16225 into H minus 0.1109 into O plus 0.0628 into N plus 0.10465 into S. If the above material is gasified in a fluidized bed gasifier, what will be the composition of syngas when peat to oxygen ratio is maintained at 0.8 mass by mass basis, and steam to peat ratio is also maintained as 0.1 mass by mass basis. Assume CO is to H2 ratio in syngas as 2:1 volume by volume, and then ignore the presence of other impurities and consider the molecular weight of the ash as 56. Also calculate the yield of hydrogen and carbon monoxide, and why the carbon monoxide and hydrogen content is so low, how it can be improved. So, this is the problem statement. So, it has number of parts So, we will be solving this problem step by step. So, this is a gasification problem and the composition of the sample feedstock is given, and then we have to find out the molecular weight and molecular formula of the feedstock first of the peat sample. Then we will convert it into its percentage, we will convert it into dry basis. Then we will use this formula for the HHV calculation. So, in two different basis, wet basis and dry and aspri basis, we will be able to calculate the HHV. So, the first part will be done. Then we have to calculate the composition of syngas. So, composition of syngas means the feedstock will be reacting with gasifying agent and it will be producing different syngas with different compositions. So, including different gas components, and we have discussed in the previous class that gasification reactions can be presented by some generic expressions, and we will be using that, and then we will see how this mass balance is taking place, and then what are the coefficients of the different elements available in the feedstock, as well as how much moles of different gas components is produced from 1 mole of the feedstock, that we will discuss, and we will ultimately get the concentration of different gas components. Now, let us say, let us take a basis of 100 gram of peat. So, as per the statement, we have composition of the peat, that is carbon is 37.5%, hydrogen is 8.8%, oxygen is 27.6%, nitrogen 0.40%, sulfur 0.10%, moisture 20.5%, ash 5.1%. So, total we are getting 100%. So, what will be the amount of the elements present in 100 gram of peat? Carbon will be 37.5 gram as it is percentage. So, hydrogen will be 8.8 gram, then oxygen will be 27.6 gram, nitrogen will be 0.4 gram and sulfur will be 0.10 gram, moisture will be 25.5 gram, 20.5 gram, ash will be 5.1 gram. Then what will be the moles present in this sample, 100 gram sample? So, we have to divide it 37.5 by 12, the molecular weight of carbon say 12. So, that is equal to 3.125 moles we are getting, and then 8.1 by 1 for hydrogen. So, 8.1 moles we are getting. So, for oxygen 27.6 divided by 16. So, we are getting 1.725, and then nitrogen 0.4 divided by 14, we are getting 0.0286 moles, and for sulfur 0.10 divided by 32. So, we are getting 0.0031 moles, and for moisture 20.5 divided by 18, we are getting 1.139 moles, and for ash 5.1 divided by 56, it is given the molecular weight of ash is 56. So, we are getting 0.091 moles. Now, this moisture will contribute hydrogen and oxygen H2O. So, it will be also having hydrogen and oxygen. So, if we want to know the hydrogen and oxygen content in moisture, then we can say oxygen from the moisture is the same. If 1 mole, then oxygen is also 1. So, that is equal to 1.139 moles, but hydrogen, that is there are 2 moles of hydrogen in 1 mole of moisture. So, that will be 2 into 1.139. So, 2.278 moles. Now, we are getting these are the number of moles present in this amount of peat. So, we can represent the molecular formula as C 3.125, H 8.8, O 1.725, N 0.0286, sulfur 0.0031, ash is equal to 0.091 and H2O 1.139 as we are getting here. Or if we use this, replace this moisture in terms of oxygen and hydrogen, then we can get this formula, where these are same, only hydrogen and oxygen coefficients are changed. So, 8.8. So, the 2 plus 2 into 1.139. So, 11.079, and for oxygen 1.725 plus 1.139. So, that is equal to 2.864. So, these are the molecular formula of the Peat sample. So, one part of the first question is done. Then we will see the heating value. So, if we want to see the heating value, we have to in two different bases. As such, we can calculate the weight basis using the same composition provided in the statement. Otherwise, you have to convert it into the dry and ash-free basis. Then we will use the compositions of different elements in the HHV calculation expression. So, here we see compositions on dry and ash-free basis. Carbon we have 37.5 original sample. So, in dry and ash-free basis, that 37.5 into 100 divided by 100 minus moisture minus ash. So, that is 100 minus 20.5 minus 5.1. So, this expression is giving us 50.4%. So, 50.4% carbon on dry and ash-free basis. Similarly, hydrogen will be getting 8.8 into 100 by 100 minus 20.5 minus 5.1, that is equal to 11.83%. So, similarly, oxygen is 37.10% and nitrogen is 0.54% and sulfur is 0.13%. Now, we are getting the composition of different elements in dry and ash-free basis. Then what will be the HHV? If we want to calculate the HHV on dry and ash-free basis, this composition we will use, but if we want to calculate this on weight basis, we will be using the composition of this, which is originally available in this case. So, what will be the HHV in case of dry and ash-free basis? We will put this, the expression is given, this is the expression. So, in this expression, C is the percentage of carbon, H is the percentage of hydrogen, oxygen is the percentage of oxygen, N is percentage of nitrogen and S is percentage of sulfur. So, HHV 0.3516 into 50.54 and then 1.16225 into 11.83 and then 0.1109 into oxygen, that is 37.10 we are putting here, and plus 0.0628 into nitrogen, that is 0.54 we are putting here, and then 0.10465 into sulfur, that is 0.13. So, this much. So, we are getting by calculation HHV is equal to 27.40 megajoule per kg dry and ash-free basis. But if we want to get it on weight basis, that will be 37.5 for carbon, this is for hydrogen, this is for oxygen and this is for nitrogen and this is for sulfur. So, we are getting 20.387 megajoule per kg. So, this is for weight basis and this is dry and ash-free basis. So, first part of the problem is solved. Now, we have to see what will be the composition of the syngas. So, for that we will be assuming the expression, generalized expressions which is used to represent the gasification of some carbonaceous feedstock. Here we see Ca, Hb, Oc, Nd, Se, Sn. This is the general formula of the Peat sample. Then it will be reacting with gasifying agents, one is oxygen, another is steam. So, we are assuming that 1 mole reacts with G mole of oxygen and F mole of H2O. So, this is the expressions we are assuming, and it will give us H mole of CO2, I mole of H2, J mole of CO, D by 2 mole of N2, K mole of SO2 and M mole of H2O and N mole of ash. Now, we have molecular formula we have just derived, that C this one. Now, if we compare this and this, then we can get the value of A, B, C, D, E and N, and from this we are getting H, I, J, D by 2, K, M, N, and we are also using G and F. So, there is some relationship. we will be trying to find out the relationship by mass balance, individual component balance, and then we will try to get the value of H, I, J, D, K, M, N, F, G, etc. And we will be able to know 1 mole of feedstock will produce how many mole of this gas composition. So, it will be easy to determine the individual gas components, the moles of individual gas components, and total gas components will get total moles, then we will get the percentage of individual gas component on mole basis. So, this is the approach. Now, let us see. So, if we compare this, so what we are getting A carbon balance, here A is equal to H plus J. So, A is equal to H plus J, again this A is equal to 3.125. So, this A equal to H plus J equal to 3.125. Now, hydrogen balance if we see, so left side is B, so B plus 2F, left side expression B plus 2F, and this is equal to 2I plus 2M. So, 2I plus 2M. So, this is equal to the expression by hydrogen balance. Then for oxygen balance, here we are getting C plus F plus 2G, left hand side, right hand side 2H plus J plus 2K plus M, this we are getting. And for nitrogen balance, here left side is D and right side is D by 2 into 2 D. So, both side matching, and this D value is equal to this one. So, 0.0286, and then E is equal to sulfur balance. So, left side is E, right side is K. So, E is equal to K, and that value we can get from the sulfur 0.0031. And then here we are getting left hand side N for ash, and here also we are getting N for ash. So, both will be same. So, N we are getting the value is equal to 0.091. Now, some of the coefficients value we have come to know, the rest we have to know. For that, let us see the molecular weight of this. So, we will put the value of molecular mass of this, and we will be getting 99.81, that is equal to say 100 gram. We assumed the previously that 100 gram samples we are getting now. Now, mass of peat by mass of oxygen, it is given, that is equal to 0.8, the problem statement says. And if this, then mass of oxygen used per mole of peat is equal to 99.8156 divided by 0.8. So, this gram, that is equal to 124.77 divided by 32. So, it will come 3.899 moles. So, mass of oxygen used per mole of peat is equal to this much. Hence, moles of oxygen used per mole of peat, that is equal to 3.899 moles, that you can calculate. Then another information is also given in the problem statement, that we will consider here, that is mass of steam by mass of peat 0.1, it is given. So, H2O used during gasification equal to how much? The H2 is giving the steam. So, that is equal to 0.1 into how much peat we have used, 99.8156. So, that is giving us this gram or 0.555 moles divided by 18. So, it will give me this gram to moles conversion. Then this steam was used for the reactions. So, we had some expression there F. So, this F was used for the gasification. Now, we are able to get the value of F. So, the value of F is given here, that is 0.555, and also we have seen that H plus J is equal to 3.125, and H and J value. Now, we will use this formula B plus 2F equal to 2I plus 2M. So, if we put the value of B, B is equal to how much? We are having 11.078, and then F we have calculated, and then we will put here, we will get the value of 2I plus 2M. So, that is done here. H plus J equal to this much. So, B and this equal to 2I plus 2M. So, this equal to this much 2I plus 2M. If we add this, so 12.188. So, I plus M is coming 6.094. We are marking it as expression A. Then another expressions we had, this one C plus F plus 2G is equal to 2H plus J plus 2K plus M. We will use this formula now. We have get the value of C, F, and then we have get the value of H. We have got the value of C, F, and now we will try to get the other values. So, here this C, F, and this one, and this equal to this. So, these other values are known. Again we see here H plus J this one, and J value is also here, I and J, that relationship is also given, that is J is equal to 2I, CO and H2 ratio is 2. So, J is equal to 2I, it is given in the syngas. So, in this expression H plus J equal to 3.125 can be, this J can be replaced by I. So, H plus 2I equal to 3.125. So, this expression we are giving as B, and which we have got here this expression, that is equal to 11.217. By this side left hand side we are getting by addition of this 11.217. So, we can get 2H plus 2I plus M is equal to 11.217 minus this one 2 into 0.0031. So, that is equal to coming equal to 11.211. So, we are marking it as C. So, we are getting some new expressions. Then by C minus B we can get this expression 2H plus 2I plus M minus H minus 2I. So, we will be putting the value of this expression. So, then the right hand side of C and B. So, this equal to this. So, H, this I is cancelled. So, H, so H plus M is equal to 8.086 is another expression we are getting. Again another operation, if we do D minus A, then we can get H plus M minus I minus M, that is equal to 8.088 minus 6.094. So, this divided this minus this equal to this one, and here again M cuts. So, H plus H minus I is equal to this one, another expression we are giving, that E. Another step, if we follow the 2 into E plus B, then we get this plus this equal to this plus this, or 2I cancel, 3H equal to this one, H equal to 2.37. So, another expression we are getting, that is equal to F. So, putting the value of H, the value of H in B, we get H plus 2I equal to this one, or 2I equal to this minus the value of H, that is 2.37, that is equal to 0.754. So, I is equal to divided by 2. So, 3.77, that is another expression we are giving at G. Now, from G and A we can get M is equal to this minus this equal to this one. So, now we have got the value of all the coefficients. So, on the basis of those coefficients we are getting the composition of syngas, that is CO2 is equal to 2.37 mole and H2 is equal to 0.377 moles, CO is equal to 0.75 mole, nitrogen is equal to this divided by 2. So, 0.0143 moles, SO2 is 0.0031 moles, H2O is 5.717 moles. So, total moles if we get, that is 9.2354 moles. So, what will be the percentage? Percentage of CO2, that is equal to 2.37 into 100 divided by 9.2354. So, it is becoming 25.66%. Similarly, for hydrogen it will be 0.377 into 100 divided by 9.2354. So, it is coming 4.1%. So, for carbon monoxide 0.754 into 100 divided by 9.2354, that is equal to 8.2%. Similar way, we can calculate the percentage of nitrogen as 0.155% and SO2 as 0.034% and H2 as 61.90%. So, these are the percentage of different components in the syngas. Then the third part we have to solve, that is the hydrogen yield and carbon monoxide yield. So, what is the definition of hydrogen yield? Hydrogen yield, we know that amount of hydrogen present or hydrogen atoms in the syngas divided by hydrogen atoms injected in the feed. So, carbon monoxide yield is equal to carbon atoms in the formed CO divided by carbon atoms injected. So, in this case, what is the carbon atoms formed, that is CO, the moles of CO, that is equal to J, that is equal to 0.754 we have got, and then carbon atoms in feed equal to how much, it was given A, that is 3.125. So, what is the CO yield, that is this divided by this, so 0.241. And for hydrogen, what is the hydrogen atom in syngas equal to 2I, that is 0.754, and hydrogen atom in feed equal to B, that was 11.078 we have calculated, and then hydrogen yield equal to this divided by this. So, it is coming as equal to 0.068, but these yield are not very high. The CO and H2 content is low because more oxygen. You see in this case the oxygen by Peat was 1.25 or Peat by oxygen was 0.8. So, which is in the higher range 0.68, it is the typical value we had discussed in case of coal for gasification, here it is 0.8. So, more oxygen is provided. So, CO is converted to CO2, that is why we are getting here less CO and H2, and then reducing the oxygen by Peat ratio as well as providing less steam, the CO and H2 content in syngas can be increased. So, now the whole problem is solved. Now, problem number 4, the statement says that a low grade coal is combusted in a fixed bed reactor. The composition of the flue gas on dry basis emitting from it is as follows. So, 12.3% CO2, 5.1% O2 and the rest is nitrogen. So, from this data calculate the weight ratio of hydrogen to carbon in the coal, the percent carbon and hydrogen in the dry coal and the percent excess air used. So, here the flue gas composition is given. So, what happens in case of combustion, the steam is produced and which is also available with the flue gas. So, that flue gas after cooling the moisture is reduced, that is present in dry phase. So, dry basis that composition is given here, basically CO2 and oxygen and rest is nitrogen. So, these are a simplification case we have it is given here, other impurities are not considered. So, on the basis of this information we have calculate how much CO and hydrogen ratio was present in the original feedstock and what percentage of excess air was used. Now, let us solve it. So, we are taking 100 mole of dry flue gas, this is our basis. Then what will be the CO2, as it is 12.3% and O2 5.1%. So, this 12.3 moles and 5.1 moles it will be, and inert will be rest of it. So, 100 minus 12.3 minus 5.1, that is equal to 82.6%. So, 82.6 moles will be. So, oxygen available with supplied air, that is equal to how much, 82.6. So, we are assuming that 21% is oxygen, rest is nitrogen. So, this into 21 divided by 79. So, 22 moles. So, 22 moles of oxygen is supplied and that oxygen will react with carbon dioxide and that will react with oxygen will react with carbon and produce CO2 and this will also react with hydrogen and form H2O as per these expressions. So, oxygen consumed during combustion equal to how much, we had 22 moles and now we are having 5.1 moles. So, this difference, the 16.9 moles was used during combustion through these two reactions. two types of reactions took place. Then from the flue gas composition, it is evident that the coal sample does not contain sulfur, chloride and nitrogen. Thus 12.3 mole of O2 is consumed by carbon during combustion as per these expressions. So 1 mole 1 mole. So 12.3 mole oxygen is consumed by carbon. Similarly, oxygen consumed by hydrogen equal to 22 minus 12.3 minus 5.1. So 4.6 mole. Now hydrogen present in coal equal to how much? Because this 1 mole of oxygen is consumed by 2 mole of hydrogen. So 2 mole of hydrogen is present on it. So 9.2 moles. Weight of hydrogen in coal equal to 9.2 into 2 molecular weight of hydrogen. So 18.4 gram. Weight of carbon in coal equal to how much? 12 into 12.3 moles, that is equal to 147.6 gram. So weight hydrogen to carbon ratio in coal, so 18.4 by 147.6, that is equal to 0.125, and the percentage carbon in dry coal, that is equal to, we will just convert it, this 147 divided by 147.6 plus 18.4 into 100. So this is the percentage basis, this much, and hydrogen will be how much? This is hydrogen 18.4 divided by this into 100. So that is 11.08%, and excess air supplied equal to how much? 5.1 mole excess, and total how much we have supplied, that is 22, and what was used? 22 minus 5.1. So that was the required amount. So what is the excess percentage? 5.1 divided by this minus this, that is equal to 30.18%. Okay, so now we have solved all the problems on this tutorial. So thank you very much for your patience.